Okay, welcome back to the channel, everybody. So today we've got a pretty fun project. We're going to be building this tensile tester. It was super simple to build, really easy materials to find, and kept the budget pretty low on this one. So if you stick around, I even throw in some testing at the end and some aluminum parts made off of the CNC machine. So stick around, and it's going to be a pretty fun one today. Okay, so before we get into the testing, I wanted to hurry and give you a quick run through of the components that I chose to use. So obviously you can tell just 2x4s, nothing fancy. Did some grabber screws, pretty easy there. I bought this linear actuator off of Amazon. I think it's got a 6-inch stroke there, so that's plenty enough. I almost went for a 4-inch, but anyway, it is what it is. So I did that, and then this is a 3D printed box. I chose to custom make that so that I could get, uh, basically recess these letters into the part to make that a little cleaner. So I mounted the switch that actually came with the linear actuator just right there on the box. Then I just got a 12-volt DC power supply. That's pretty simple. These clamps, I tried to find clamps all over the internet. Really couldn't find great ones for the level of difficulty of project I was going for. So I wanted something that was strong enough to hold the parts, but maybe not like overkill, like that you'd find on actual like jaws that you'd actually find on a real tensile tester. One of those like several $1,000 machines. So I went with some cheap camera mounting equipment. It's actually meant to like basically clamp to a pole, and then it's got some threaded holes there to hook your camera equipment to. I've used these on other projects, and so I've opted for that. Seems like it's going to work good enough, and with the little bit of testing that I've done so far, they've held up pretty good. I plan to, in a future video, I plan to use this CNC mill here to basically mill out parts out of aluminum to make my own clamps for my own jaws here. This is one that I just 3D printed to kind of test the concept. But basically what I want to do is use like a wing nut or just some easy like thumb screw type thing here to basically clamp down on an aluminum jaw for this. And that's why I got these shackles here, so that it could basically fit right in there. And then that would be my jaws, and it would allow for a lot more contact with the parts and just a better design there. So That's a future project though. I've got the designs for it, and I just need to get working on the cam and all that for it. So that'll be upcoming. If you want to see that video, please subscribe to our channel, and that'll be coming up. So moving on here, we've got the sensor. It's just a, I forget, well, it's a 400 kilogram scale. It's, I believe, like 800 pounds. Don't quote me on that. You'll see a corrected number on the screen here. But then just some, these two parts came with the actual scale here, and then I just bought these shackles separate so that I could use my custom made jaws for it. But I needed to use these shackles for that part. Anyway, so yeah, that's kind of a quick rundown of the tensile tester, and yeah, let's see what this thing can do. Okay, so these are my custom made dog bone test specimens for my tensile tester. I made these out of just regular PLA plastic, so nothing fancy there. Just 3D printed those. I've also got some aluminum, the same part, but I made these out of aluminum on the CNC machine. Different load tensile forces, so I'll show those on the screen as well so that we can get that data later, and both what we expect as well as what the actual readings from our sensor is. So let's load one of these samples up. I always like to start with the more simple part first. So the important part is to not clamp this too tight. I did that in a couple tests when I first got this thing, and it was actually pinching the plastic, so it was kind of deforming the plastic, making it weaker. So it's important to just, tighten it to where it's not going to slip out, but not necessarily to where you're deforming the part. So it's a little tricky, and this is why I want to do my own custom jaws, is because it's a little tricky keeping this all with the rope, paracord, and all that. So, all right, looks good. And you can do this horizontally. I chose to do it vertical just for the video, but I actually kind of prefer doing it on a table, flat on a table, so that yeah, it just kind of contains everything better. It sits a little bit better, and so, but nonetheless, let's give this a whirl. So on our scale here. Okay, so yeah, on our scale, we've got the ability to, basically it will hold at the maximum loading that it saw. So I'll just give you a little test. When I pull down, it freezes at the max load that it saw. So, which is useful for our application. And I kind of had to search a little bit to find a scale like that. They are out there. It's just, yeah, you just want to make sure it has that feature built into it. So we're gonna go ahead and zero that out, and then yeah, we're gonna get going here. And I should probably put on some safety glasses here. Okay, let's give this a whirl. So you just pull down on the switch is the way I have it set up. So and it didn't work. Now this is actually something, it's a weird bug glitch with this thing. For whatever reason, it like reverts back to 0, but then if you just kind of slightly tug on it, you can see it goes up to 122. So I don't know why it does that. It doesn't always do that. It only sometimes does that. So anyway, got to figure that out. I don't know what's going on there. Probably just a cheap scale. I don't know. Anyway, so it looks like we got that one at 122. 122 pounds for, oh, let me tighten that one in there. Okay. Now I got another one here, let's load it up. Once you get the thickness dialed in there, it's pretty easy to just swap them out in and out. And then, to reset, just hold the switch up, reset that. Perfect. Anyway, I'm gonna get this loaded up and we're gonna do a few more. Okay, take 2. This is the second test here. Okay, let's let's see what that one held to. 96. Okay, take 3. This is the third test here. Okay, that one is at 115. This is the fourth test here. Okay, and that one broke at 118.1 pounds. Okay, so up until now, we've only been doing, these PLA 3D printed test specimens, and they've worked really well. I designed these specifically to fail at 100 pounds of force based on the tensile strength rating that comes from the manufacturer. From Bamboo Lab, they have a tensile strength on all of their filaments, and if you just look that up for PLA, I designed this based on that, and let me know in the comments if you'd like to see how I did those calculations. It's pretty easy and pretty simple, but nonetheless, if you'd like to see that in a future video, let me know. But I've gone ahead and I've milled out of aluminum 2 additional specimens here using essentially the same geometry except for the thickness here, and I specifically made it with 6061 aluminum tensile strength. I designed this so that it will fail at 200 pounds, so hypothetically double what those were failing at, just to see, is it the CNC machine? It can obviously get a lot more exact parts, and I've shown that in previous videos with the accuracy and the tolerances. I've shown that in a different video. I'll maybe link that in the description below. But I'm hoping to find out through this test to kind of see, compare, is it an inaccuracy of the sensor, of the scale here? Is it an inaccuracy of the 3D printed parts? Maybe there's like voids inside of them, or is it a kind of help me hone in and really refine my approach here. So let's get this loaded up and do some aluminum here. So I've gone ahead and I've got the aluminum test piece loaded in the machine here. I've zeroed out the scale and got my eye protection on. So let's go ahead and give this a try. It should fail at 200 pounds. That's what we're shooting for anyway, if our design is correct and the material properties, all that. All right, let's get going. Okay, let's see here. 205. Wow. That's actually pretty good. That's well within the tolerances. Interesting. So if you know much about material properties, and I'm no expert on this by any means, but I do remember from my undergraduate days that I forget the terminology, but like that fractures typically happen at like 45 degrees from one another. And look at that. That is, that's the thin face, and then when you look at it at the angle, it's almost exactly 45 degrees. That's really interesting. It deformed a little bit, you can see. I'll maybe show some close-up shots of that, but failed exactly right where it should have, in the middle of the part at the thinnest point. And wow, within 5 degrees, that's pretty impressive. I'm really happy with that. So let's go ahead and give the second one a try and see how that one does. Okay, I've got the second aluminum piece loaded in here. Let's give this one a try. Again, 200 pounds is what we're shooting for. Okay, let's see what that one did. 208. Okay, so that's I'm feeling pretty good about that. I'd like to maybe in the future get some known weights, some certified weights to be able to throw on this machine and calibrate it more accurately, because that could be causing some of this inaccuracy. But look at that, almost an exact copy of the last piece that we did. 45 degrees. Yeah, that's That's pretty impressive right there in the middle, just the way we designed it. So this is confirming a lot of the older the previous thoughts that I've had to be able to design various parts. I mean, this is what engineering is, mechanical engineering. We do this every day with different parts and different things throughout, just, everything. Cars to airplanes to houses to everything is designed to test these strengths and figure out material properties so that then we can use that in our design approach. Stay tuned though, because I'd like to make a future video on making rings. I want to do some tensile testing of rings, and maybe buying some just off the shelf from like Amazon or wherever, maybe even some of those silicone type ones, and testing them and seeing how are they designed and where do they fail, and see if we can create a more safe ring, in case you get it snagged on something. We don't want to be pulling off any limbs here. So anyway, this worked really good today, so I'm pretty happy with that. Pretty happy with the way it turned out. Okay, thanks for tuning in on this build. It's been a super fun project to put this together. It's something I've wanted to do for a really long time. Like since I was in college, I've had this as a goal of mine, and finally got a machine so I can really put it to use with the CNC machine and 3D printing to really start understanding some of these different materials and designs, and to use that to inform my own designs going forward. So if you've liked this project, let me know, and I can start, maybe making some more videos about how we did this, or, let me know what you want to see, whether it's testing different components or materials, or I've even thought about doing maybe even like a contest, where you guys design some parts, and maybe, there's a general theme, maybe it is a ring or something like that, and you guys design your own parts, and then send me those designs, and I test them here and see if we can hone in on some pretty cool designs moving forward. So if you've liked this video, if you like this content, please subscribe to our channel, and it really helps grow our channel and get more awareness on some of these STEM and engineering type concepts like this. So until next time, have a good one.